point.
We don't want to have you be pulling a Mr. Redden here.
Right? Can't pull a Mr. Redden. So good morning, everyone. This is a little bit of a warm up for you. And if you looked at the cross product video, which you didn't need to do because we're doing it tomorrow, you have a little bit more you can try. The first one's pretty easy. What'd you guys get for this part over here on the left? How do we find dot product first, or how do we find the angle?
Does anybody know the equation for finding the angle?
Yeah, if you don't know the equation for finding the angle, it becomes an impossible task without plotting it and guessing.
Oh, you're thinking going straight to the angle instead of the base equation. I know what you're talking about. But one for dot product. It's not a marker that it works.
So there's a couple ways you can remember it. You can remember it as u dot v equals magnitude of u, magnitude of v cosine of theta, which is the angle between them. Or another way is just going straight with cosine theta is the dot product over the magnitudes. So what's the dot product here? 0. The top is 0, so it doesn't even matter what the magnitudes are. We don't even need to calculate the magnitudes. What does that tell us about the angle?
Yeah, you're right. 90 degrees.
It's 90 degrees, or pi over 2. These vectors are, what do we call vectors that are at 90 degrees?
AR. It starts with an O. Orthogonal.
Orthogonal. All right, so we could do the same thing over here. This one, I knew how to do that. I did a XY vectors because I knew I could come up with orthogonal vectors really quickly. The other two, I just simply picked random numbers, so I have no idea where this is going. So let's figure out the dot product first. I've got 1 times u dot v. Let's call that u and that v. We've got 1 times 10 is 10 plus 2 times -6 is -12 plus 3 times 7 is 21. Looks like I've got 19. Now we got to figure out what the magnitudes are. Magnitude of u is square root of 1 plus 4 plus 9. Each of those numbers squared. Magnitude of v is Let's see, 10 squared is 100, negative 6 squared is 36, 7 squared is 49. So this is root 14. This is, let's see, 185. So cosine theta equals 19 over 14 and root 185. This becomes calculator work. So I'm getting cosine theta equals approximately 0.37, but I'm not going to use 0.37. I'll just do cosine inverse of the answer. And I'm getting 1.188. I'm guessing that's in radians. 1.188 radians. So times 180 divided by pi is approximately 68 degrees. So if you looked at the cross product or you didn't, this would be a quick lesson for you. Let me rewrite U and V here so I can use them. We do I, J, K across the top. Then we do U1, U2, U3, B1, B2, B3. And we follow a pattern. We can go across any row. I prefer going across the top row because we don't have to worry about signs or anything. Let's set up our cross product here. So if I go across the top row, the first thing I do is I cross out or I ignore the I row and I do a determinant on what remains of the 2 by 2 down below. 2 times 7 is 14 minus 3 times negative 6 is negative 18. That's in the I hat direction. Then we do J hat. J hat is negative. The second one, the even one, is negative. So we'll do minus J or minus whatever this is, J hat. And then we'll have plus something K hat. J hat, we do the 2 by 2 matrix if we ignore the middle column. So 1 times 7 is 7, minus 3 times 10 is 30. And finally, K, that matrix, the determinant of that 2 by 2 is negative 6 minus 20. Looks like we get, what is that, 32? 32 I hat. This is negative 37, makes it, or not, sorry, it's negative 23,
Negative
make it
23.
positive, is positive 23. And then we got minus 26K.
Mhm.
Or we can write this as 32, 23, negative 26. So if we were to draw U and V, I'm not plotting those figures. I'm just doing a quick sketch. Let's see. U and V, if I do the right hand rule, U is here, V is here. The cross product's coming out of the page. So it would be coming straight up towards us. And it makes a right angle with both of those vectors. Now, if this was labeled the other way, if this was V and this was U, then the vector would point into the page. But still make a right angle with each of those things. So it takes two vectors and makes a vector orthogonal of both. So basically that orthogonal vector, if U and V are in the same plane, well, they will make a plane. Let's call this W. The cross product is W. Let's call that W. W is normal to the plane containing U and V. And normal means orthogonal in terms of planes. It either goes straight out of the plane or straight into the plane. That's your quick little warm up and stuff this morning. Do we have any questions today?
I'm hearing I'm super lost. Are you not understanding how the cross product works, or are you not understanding how the vectors are, what the vectors are doing? Oh, yeah, so they're not understanding completely how the cross product works.
Okay. Have you guys watched the cross product videos yet?
Did you watch it? Yeah, it'll probably help.
Okay, watch the videos, and if you don't understand, ask me the same question again tomorrow.
Yeah, so if you watch the cross product video, this should make some more sense than it would be if you didn't.
Right.
But you did. It was not assigned today. It was assigned for tomorrow.
Yeah.
We're asking to find an angle. So what's this cross product?
You're there. The angle. I'm pretty sure that was the last question, wasn't it? Yeah. This is a different question, right?
Yeah, this was just doing the cross product. That angle we calculated was, apparently I didn't sketch it very well. That would have been the 68 degrees right there.
Oh. But that wasn't the question we were answering for this.
Right. I had them do the dot product, and they said, if you watch the cross product, do that too.
Do that too.
So if you haven't watched it, this is your intro to it. What we do is we make a 3x3 matrix. We put I, J, and K across the top, the unit vectors, and we put U in one row and V in another. As you're going through it, go across the top, go across the I, J, K. And for each one, you're going to, whatever letter you're on, cover up that row is the easiest way to do it. Until you're quick, you can do it quickly without doing it, cover it up. I have a 2x2 matrix of numbers right here. The 2, 7, the 3, -6. So I did a determinant on that. 2 times 7 minus 3 times -6. So that's where I got the 14 and the -18.
It might be easier to show it like this, more expanded form. So I'm going to write it on the board here.
Okay.
Where U is.
Oh, that's a -18. It looks like a 7.
1, 2, 3.
I would like. I think it's 78. That's huge. That makes more sense. That makes a lot more sense. How do you like this? Like 3 times 6. Yeah, like minus like 1/3.
And using this to show how you get 2x2 matrices. See that you get a 2, 3, -6, 7, 5, minus.
Then when we switch to J,
It turns negative, so it's 10, 7, J plus, which is 1, 2, 10, negative 6, 1, 6. And then with doing 2 by 2 matrices, you multiply this, multiply this, multiply this. That gives you the 214 minus the negative 18 I. This gives you the 7 minus 30 J hat. This gives you the negative 6 plus 20.
you guys are doing math trivia in class. That's just
That looks
dirty.
about right, right? Or can you can't even see it.
I can't see it.
Yeah. It's a little hard to see, but basically I just split it into 3 2 by 2 matrices instead. I figured that would make it a little easier to understand. Here, I'll take a picture of it. Yeah. Are you gonna do another example?
I can, if you guys want another example.
You guys want another example? All right, go ahead.
I'm gonna let you guys tell me what the vectors are. Let's pick 2 vectors. Give me, they gotta be 3-dimensional. So
All right.
what will be vector U?
All right, pick a number, everybody. 4, 2, 7. Somewhere around there.
All right, now what about B?
0, 0, 0.
I see a 0.
0 is lame. I'm not doing 0. Pick a different number.
8.
8. I heard 8.
And then I hear an 8 as the last one then.
What are the 3 here?
We'll do like 6, 9, and 8. But you could do 8, 6, 9. That's fine.
All right, you guys try that according to what we just did. I know Brandon's got it on the board. See what you come up with, and then we'll do it together in like 3 minutes, 3 or 4 minutes. How's that sound?
This is for cross product. Yes. So what it does,
No, honestly, I mean,
Sum of squares of sides. Not product.
Yeah. Yeah, it's a little hard to draw. I know. Yeah.
That finger.
this for like, I was just thinking it's like grades. So like, if it goes over like 3-dimensional or 3 or more.
Oh yeah, yeah. We go to 4 dimensions as well in the spots. You were joking outside. We're actually. Oh, rude. Like, if I point you,
Yeah.
what dimension?
I like to do that.
Is there any questions like how like to find the cross product using matrices? Yeah, so technically matrices are linear. Linear algebra, but this is an application of it. That's tried. Yeah, this will technically be a new vector. You can call it U cross Z, but you could also call it something else. Like vectors. I don't know. Okay, well, imagine just like we just try to be like, oh, this is it's just different. I can't believe it's just happy Wednesday, everybody. Okay. 1, 2, 5. There you are bored. I was bored 3 months ago. Mr. Jones, you know what I heard? I heard
What'd you
that
hear?
someone was saying chapter 11 was too easy. Now, I think they're saying that they want a really difficult test to really challenge them. Make sure that they have these ideas really set.
I can do that for you. And if chapter 11 is too easy, I will bring you a more difficult chapter next. I will do this for you because I care. I'm here for you. I want you to learn as much as you can.
Don't worry. Even if they're thinking chapter 11 is too easy, I'm sure they'll find the future chapters to be fitting for their difficulty level.
Did you guys get that for the cross product?
I did.
Good. All right. If you guys got this, well, either way, this is the vector you should get. Your next challenge, should you choose to accept the mission, show that W is orthogonal to both U and B.
Yeah, the reason why you get that is one's negative. It's something I saw. I didn't look into it that 11. Okay. But I'm good at keep trying to push that forward for get better at it.
That's what Cosmo and Val asked in the beginning
Definitely won't make my career.
when Tip CC was started.
Yes. Vacation is you're typically going to use this.
Did you guys show it was orthogonal?
So basically.
Are you guys working on that?
Everything happened.
Whether he, whether he's very or not. You're gonna want that notation. It will, if you combine like regular variables with the vectors, I'll make some. So basically, you're gonna want that.
So who's checking the orthogonality with W?
Right again. W is what we're talking about.
Was normally the book.
Oh, I see. Oh, you have to, and. I don't. Oh.
You're at a peanut butter.
Yeah, like my AP Calc teacher, I would say, I wish this problem were easier method.
I'm going to make it easier. Let's factor out 4.
Yes, we got a question.
So just to check to make sure that it's orthogonal, we would just multiply W by either U or V, right? And assuming that we get 0 once we add them together, we go without product, and it's orthogonal.
When they were saying to multiply it by U or V to check if it's orthogonal, you multiply it by U or V to see if it's 0. That's what someone was saying. By W.
The dot product, if the dot product is 0, they're orthogonal.
Okay, right. So that would be a way to check this. So I could take U or V and multiply either or by W. And if I get 0 once I do the dot product, then I know it's orthogonal.
I don't want to use the word multiply. I want to say dot product, because both dot product and cross product are a form of multiplication. But yes, you are multiplying them by it. I'm going to do V dot W as well. And notice I factored out the 4 to make it the math a little bit easier. Because I can put the 4 at the end. And 4 times -6 is -24. Plus 2 times 10 is 10. Plus 7 times 2 is 14 times 4. But this adds up to 0. So 0 times 4 is 0. So rather than using big numbers that I cannot multiply very well with in my head, 8 times -24 sounds like a bunch of horse shit, but I can do 8 times -6 pretty easy. -48 plus 30 plus 18 times 4. 0 times 4, 0. Check. W is in fact orthogonal.
Doesn't look like there's any questions.
Feel
Yeah,
free to work on homework and stuff if you don't have any questions. How about the people online?
I don't have any questions. Thank you.
Good.
How would you find it over? I really want to make sure.
So what is, you have, what is cost market for? It'll give you a normal between two vectors. So you need to do normal vector. Yes, so that means you need to. Yeah. Although you're. No, I'm sorry.
Why am I trying to be?
I'm just making sure that. Okay. So you're not understanding what this question is asking.
Yeah.
Yeah, so yeah, normal means that it's something that you know predictable. Yeah. That's what it's that's actually typical, not just an English story. That's typically just a math term to know. So I wouldn't worry about it.
I don't ask that question, man. That's the problem. Sometimes I really know you.
Well, I wouldn't say, I'm saying don't be too hard on yourself if you don't understand and that. But, okay, so anyway, so you're finding a vector. So it's pretty quick. You can't. So
There's a free line. It's three, top points. So I can pick up any of the top points. Right.
So what you would have to find is you have to find two vectors. If you remember how to get a vector between 2 points. So try starting by finding two vectors between these 2 points. And then take those two vectors, cross them, and you can flip them, and now you'll get a negative version of the same thing.
Well, we got it right now.
So there, so we imagine that these 3 points are in the same plane.
Oh,
Yeah.
Oh.
You gotta calculate the
How do you feel about
I'm not actually, you know what? Last time, one of the last time, high school, like, yeah. So I went to Wendy's. And I had like uploaded.
I need to find
I took like one bite and I was like, I'm done. And I didn't speak for
What's the question for the recommend?
That's why I experienced that. So pretty bad. I'm not used to food that is just short ribs. What do you eat? Real
Just
food?
water.
Just water.
Water. That's what I had. Water.
Actually, it wasn't too long ago that I didn't eat.
Just like for this.
It's not a breath of fresh air you can find around here. That's actually. It's crazy.
Nobody going.
Hope you were able to finish your bean burrito. I mean, after all, it's gonna be 20% is great. That's all. Yeah, that's all pretty good.
How many people ended up showing up today, Brandon?
Like, let's see, 15. 15. I'd say a little more than half a class.
Awesome, good.
Well, like a lot of people have already left.
I think doing a lot of examples where I give it to you guys, let you guys work on it a while, and then I do it might be the best way to go forward with this. I think today worked pretty well. We'll continue this.
Yeah, I really like this method, like getting examples and then you helping us work through them.
Yeah, this is my first time doing this whole flipped class model, and figuring out what to do with the in-class component isn't necessarily intuitive, but I think this works well. Thank you. I'm glad you like it.
High school, I finished you say you put on the board. If you finish your intentional license, you would actually about like trying to set a tangent. So I was like not getting done about that. So I just made up fictional story. Yeah, it's like man, that's just like, oh, wow, it happened.
I got it right.
I feel like just like
What's up, big dog?
I'll remember that.
Joe, he looks like a shooter.
Cosmo be bribing to keep his job.
So the first one, like, projection.
That's what I mean, by the word.
Yes,
Because
because it's going
it won't ask for projection, they'll just say find the bigger component. Or E on B.
basically, yeah, because what it's basically, what it means by component, as far as I know, is that it's saying like, you can use a unit vector. And it's not, because if it was asking for the spectrum of, I think it's saying that way because if they were to say, that they wanted.
Thanks, Brandon. Oh, Jim Brandon.
Basically, they're paying, yeah, sorry. I'm not going to let me start over. But once you use projection. And once you use it that way, because you're going to have different values to find the vector that is. Then the one that has projection. And then I was doing machine what it means by finding that somebody on a video.
You subtract the pairing a little bit less.
Well,
Oh, it's not asking for H, that's for A, it's asking for.
Oh, no, never mind. I'm, yeah. Okay, yeah, my brain was working. I was thinking of this cross product, but no, it's just asking for. Yeah. I'm going to make sure. Yeah, I know where it can be weird. Mr. Jones,
Yeah,
when it says a vector component, does it usually mean like a unit vector?
no, any of these are a vector component, like the 8 is a vector component, 6 is a
Mhm.
vector component. It means like an X, Y, or Z. It doesn't need to be a unit one though.
Oh, okay.
So this is like U1, U2, U3. Those are vector components.
Oh, okay. So does that make sense?
I have to find one other.
The vector component that's
Component and not the whole vector. I'm guessing the whole vector won't be, there will be no whole vector, that's only a part of it will be.
component, which because now, yeah, because that's making it more confusing on how to answer the question now. Because the question was asking whether find the vector component that's orthogonal to or orthogonal to another vector.
You're basically finding the vector that's orthogonal to it and
Yeah.
just listing what the components are. That seems like a weird way to phrase the question though.
They really like it using the word vector component, if anything.
Is it in the book?
Yeah, it's in the book.
25 is the one that says vector component, and 27 is the one that just says after the vector itself.
Okay, number 25.
Oh, okay. I see what. Okay, so another way of wording, we have V equals like the K1 E1 plus K2 E2, where the E1 and E2 don't have to be unit vectors. These two are component, when you add them up, they're also called the components of V. That's another way of another use of the terminology.
Okay.
So they're asking you to do is break up V into two orthogonal vectors.
Yeah.
The sum of two orthogonal vectors.
Yeah. Okay. Did you have a question?
No, we, like, actually, when we gonna do that? Or circumstances, we kind of solve problems using that.
I think that's a he's asking when are we going to use that form?
Which form?
The form that you just showed to explain another way of viewing components, vector components.
The reason why you don't need to write it like that. I mean, we could write it as B plus B orthogonal. I guess here E1 kind of E2 is a unit vector. This is really what that question's asking.
Yeah.
Same thing, components. And when you might use it, you might want to know unit vectors. Like we use unit vectors in 3-space all the time with IJK.
Oh, yeah.
One common way of dealing with vectors that are not along IJK in mathematics is to rotate our entire frame of reference so that our vectors are IJK, even though it may not have started that way. Like we have a box like this, and it's much easier to work with the box like this, so we can rotate like we're rotating IJ and K. But you kind of need to know what E1, E2, and E3 would be to do this rotation. This is something you'll do rotations in linear algebra.
Oh, because I was gonna say is like that looks very similar to the Jacobian we learned later in this class.
Similar.
Yeah.
But we do a lot of rotations in linear algebra because
Okay.
it's much easier in matrix form. And that class is all about matrices.
So I've noticed.
Thank you so much.
Do you guys have, is there a class coming in after this?
Nobody's piling in at least. Let me check. Could you check on the door?
Not really, until 10:45.
Okay. There's one class after at 10:45.
I mean, you guys
Yeah.
are free to stick around and ask more questions if you want. I don't have anything that I have to do after this, so I can sit here and answer more questions.
You're talking to an empty classroom.
So.
Oh, well then. I will see you later, Brandon.
I'm still here.
I got one person.
Well.
Wow, Brandon just completely disregarding you, isn't he? That's some hateful stuff, Brandon.
So on the test day is Tuesday. After that test, they got.
Wait, Eric, it's Eric I'm hearing, right?
Yes.
Just come over in front of the camera so I can hear you better. Quit screaming.
Oh,
If there's only one of you, I can just face you.
I was always thinking you can see your class.
No, I
Well,
can't. What's up, Eric?
All right, so on the day is our first test is Tuesday. After that test, 9:10 or something, there's a hand signal class after us. So that day we gotta go.
I'm gonna
After-
be here at 7 a.m. on that day. If you can or want to come early, that will
Okay.
give you basically 2 hours to do the test rather than 1.
Nice, thank you.
That work for you?
Yep.
All right. See you tomorrow.
See ya.
See you later.